Hello, I am Passfit. Welcome back to Machine Instructions Hub. Today I am going to teaching you how can you make the functions and looping in assembly languages low-level programming used to implement machine learning. An assembly language is a human-readable language used to make the communication directly between hardware and machine learning. So today I am going to teach you how can you make the functions and loop in assembly languages. In C functions, when we are looping, we use loop initialized variable, and loop control variable, and increment. And also in C functions, we use the function have the parameters and the function without parameters, and we use the functions returning and non-return functions. So how can we implement these functions in low-level languages? Let's start to implement our functions. Our program, let's name our program. My preferred editor is Nano. I use it Nano for Carolinas or many are using Nano editor. Nano function .s. In our function, maybe we're gonna start the function that can display any text on the screen. Section data type the text we are going to print on the screen. Arrows object. Our message you want to display string or even ASCII. Our string is hello, welcome to Machine Instruction Hub. Machine instruction zone. New line. After writing this message you want to display, we are going to make the function display these instructions. Our executable code will start in section.test. Type function for base functions. It's the assembler. This type of object is function. Global for so when you are to do a function in machine instruction, you should initialize the start that can accept the variables. Push our EBP, move our ECP and EBP. Our functions will return nothing, means void the function. Void our function means no operations. Move our EBP, ECP. Popping the EBP onto the stack. Return from the procedure. And from the procedure, let's display our message on the screen. Our function. Let's display this message on the screen. Suppose move R for EA8. Move RS from EB8. Standard output file descriptor. Move R. Message in EC8. Move R. The ranks of want to display on the screen dot equal our length of message is dot equal rain or s minus message dot equal rain ED8 and then implement our system code. Let's call this function the global start. Our start main function is global start. Call our functions, call for starting to execute and then exit a program. Move R1 EA8 move R0 EB8 and then implement our system call EB8 control save. After working our function, we're gonna run our functions. See, we're using junior assembler function dot s minus o function dot o. The when stating the function invalid operand. This operand is invalid. Equal set to symbol missing directive function. You're missing symbol of directive. Object. You're missing symbol name in directive. Oh wow. Into the base object. Object dot type message. Oh wow. Add function dot o minus o function by the function. Yeah, our program implement the certain characters we can decrease 15 times. Already our functions will print hello, welcome to machine instruction zone. Welcome to machine instruction zone. That is printed by here. Welcome to machine instruction zone. So we're gonna printing these functions in our looping statement. We now know how to implement the void functions in machine instruction. For our looping statement, we're gonna display 10 characters for this one. We are using the local variable stored into the ECP start sub R8 ECP Our loop control variable is move r 0 minus 4 EBP. This is our loop initialized variable equals 0. And so it's available to loop control variable loop, and then the for loop we display this for loop, we display this, and then incrementing by 1, increment add the rs1 minus 4 EBP. After add 1 environment, the condition that can control our loop, compare with display 5 cards, compare 5 and minus 4 EBP. If minus 4 equal jump less than or equal, we both jump to for loop back again. For loop back again. Non-save a program, reassemble and delete our program. Here the functions. Wow, already I wanna display the 5 instructions for the screen. Displaying the 5, 1, 2, 3, 4, 5, 6. The reason why I incremented by 6, the looping is adding before in the condition time go jump less than, applying the 5 character or s, reload function dot s, and then reload. Or do we display the 5? Displaying the 5 output. When use this using loop, using loop in terms of the local variable, we can use this loop by using the function start. The loop control variable will be the first argument of our functions, and the loop initialized the variable will be the second argument of our functions. I'm gonna do it this way. Move up, 8 EBP EA8 move R EA8 EBP. Move up 12 EBP EA8. Move up EA8 minus 8 EBP. So our variable 8 is the loop initialized the variable. Our variable 12, certain variable 12 EBP is the loop control variable. If the loop initialized the variable is higher than loop control variable, the program will exit. If the initialized variable is lower than the loop control variable, the program will display these instructions. Let's compare this. Compare. It will contain the loop control variable. The loop initialized variable is minus 4 it will store -4 EBP. If -4 is the loop, initialize the variable, and if -4 EBP is greater than loop control variable, jump to exit. Or jump to exit. If it's not, continue our looping. Exit. Jump to our looping. Add, compare, add R, compare, EA8, EA8, yes, pushing our value into the stack, push our loop control variable, push our loop, initialize the variable, push push 0, push R, S5, save our program, and then clear the stack, add R. We're gonna put 1 into our program, LD function. This is our looping functions, and then we know how this is our functions for, and this is our loop functions. If you want to do much more techniques in machine instructions and assembly, could follow my channel. This is Machine Instructions Hub. Our next video, we're gonna teach you much more about machine instructions. If you want to learn computational science and programming and architecturalism design and somehow audio signal processing and sound engineering, beat making, you should follow my channel. Bye bye.